Simon Johnson, he's our next speaker, and he will bring a keynote for us. Simon, what are you doing normally? What's your job?
So my regular day job is kind of split into two parts. The first is, as many people know, as I've been involved with the SGX program for the best part of 11 to 12 years, and so I head up architecture development for the program. And a new responsibility I have is, as I've been in the wars, as it were, with dealing with a number of the issues that we've seen affect computer systems just recently, has been really I've been integrated into what's known as the Information Product Assurance and Security team, and so I have a senior position within there, helping us deal with security issues as they pop up. So I have a 2-for-1 responsibility.
And you will talk about scaling confidential compute. And if you're ready to share your screen, let's see if it works. And then I'll leave the stage for you.
Okay, let's see. This is a completely new platform to me. So I've got a red screen through my a red cross through my aha. All right, almost there. I've got a button mouse and it's terribly slow today, so I apologize.
Let's see. We wait until it works.
All right.
Yes, it's loading and I can see everything. So enjoy your talk.
Thank you very much. Appreciate the introduction and the invite to be here to give you a bit of a talk. I think a lot of this is going to be very, very familiar territory to folks, but what I wanted to do today was to give folks a brief view from the Intel perspective of how we view this new and exciting paradigm, and I call confidential compute a paradigm, and we'll talk a little bit more about why that's the case throughout the talk. But the reason that I talk about scaling is it's not just about providing just a single trusted execution environment, but really how is this going to really encompass the things that we do and where it has potential to go. And driving, rather than it just being a niche technology, how does it become an everyday technology? And obviously scaling that is going to be very important. So if I can drive my own screen, here we go. So I think the first thing to talk about is just the environment we find ourselves in. The data center is certainly from Intel's perspective is a massive market and a massively growing market, and there's a whole bunch of things that are impacting that, right? We've seen throughout the last year how interconnected the world is having to become, the new way of working, as it were. This not only creates demand for machines, but it also drives up the rate of data growth that we're going to see, and new usage models like connected cars, 5G are really going to massively expand that. The economics of the cloud are really helping us drive down the cost of delivering that, and so as that explodes, solutions will get more complex, and we've got to figure out, what the risks are and bash down those those risks and impediments. So that's the world we find ourselves in, and there's sort of like 4 big trends that we see our customers talking to us about in terms of how we want to what they want to really address this from a security perspective. First of all, they just want to encrypt everything, right? Whether that data is at rest, is in transit, and most recently in execution, right? This is where the confidential compute paradigm really springs from, providing isolation to their workloads and their data. And so that's how we find ourselves here. But they're also talking about how we build out, chains of trust, from the moment the platform boots all the way through to the workload being executed, and how that they can demonstrate compliance with regulatory requirements that they find themselves butting their heads up against. So that's the environment that we find ourselves really in from an Intel perspective. If you look at what's happening, in terms of the business and the technology that we're going to bring, it couldn't be a more exciting time, right? It's not just about building better CPUs, but it's about providing execution across a range of types of devices, whether that be FPGA, AI, and other types of devices that will come along. We want to be able to seamlessly allow execution to travel between the CPU and those accelerators. And at the same time, we're expecting, the cloud to be dominant, but the edge is going to get bigger and bigger and bigger. A component of, where our data is going to get processed. Certainly with the advent of 5G, as we push processing out of just the cloud and into the edge to provide seamless services. So a very, very, very exciting time to be working in this space. Now, what drives all that also is a whole bunch of brand new usages that people are interested in hearing about from or delivering, I should say, from a security perspective, and certainly in you have the sort of like the infrastructure type components, whether that be the emergence of blockchain for managing sort of like supply chain or financial transactions. You've got the cloud and the edge guys building out a massive amount of infrastructure that needs security, which means you're probably going to be encrypting things, which means you need key management. And so that's sort of like a base, a substrate of work that's going on. But then on top of that, you've got these brand new sort of like data-driven usages where we want to provide privacy to our data, whether that be in some form of multi-party compute computation or federated learning or privacy-preserving analytics. These are all sort of like rough synonyms at the gross level for each other, and certainly we have seen some very, very, very exciting usages appear in this space. So, for instance, we've been working with the University of Pennsylvania, their hospital system there. They're trying to enable 60 hospitals to share data around brain tumors whilst preserving, the privacy of their patients. And certainly that's been a very, very exciting AI/confidential compute usage that we've really seen go forward. And there are a number of others that we're working with, and that's just an example of the sorts of uses that are really driving sort of like the value prop in this space, where data is oil, data needs to be secured, and this is where confidential compute is really going to help. And so when we look at how we're going to deliver the paradigm, right, it's not just a matter of providing a simple instruction. These are complex hardware architectures we're going to bring to the platform, and I'll talk a little bit more about what we have in the roadmap in a second. But also, I think the reason for this conference is that we understand and accept that there's a lot of software that has to get written to fully leverage this type of paradigm. So let me talk in broad pictures the sorts of data innovations that we have, right? So we have this notion of things that are very, very simple to turn on, don't cost much, memory encryption being the sort of the key asset there. And so that's a simple go and turn something on in the BIOS or the operating system, and memory gets encrypted, and you have some protections from certain types of attack. What we have then on the right hand side, and so that's the simplest stuff to enable, and then towards the right hand side, right, you have the more complicated but more data isolating trusted execution technologies. And here we saw like seeing two categories appearing: VM container-based isolation and application isolation or partial application isolation that I've spent the majority of my working career at Intel on. And so that's Intel's view is that our job is to provide the best technologies in this space for whatever solution is right for the situation that our customers find themselves in. And so this is sort of the spectrum of stuff that we've been looking at. Now, I have been spending the majority of my working career, as I said early on, as involved in the SGX program. And so we've been working hard. I think SGX came to clients was first announced in 2014. We deployed in Skylake Client in 2015. And for a long time, we've been working to bring this to our multi-socket CPUs. We're able to bring this to the data center through our Xeon E series, which is a small-scale processor, mostly aimed at small and medium businesses, but certainly has applications at scale. And so we've been, working with a number of lead customers, Microsoft, IBM, Alibaba, I believe, in delivering, SGX usages in the cloud through those systems. But I am pleased to say that SGX is coming to our multiple socket Xeon scalable processors here in the near future. I don't believe that we've announced a launch date, but certainly we're now out in the open talking about that. Now, the good news is one of the common complaints that we often hear about SGX, certainly the Xeon E systems, is just not enough memory. Give us more memory. And so we have spent a lot of time figuring out how to deliver, more than ample memory to support, lots and lots of enclaves running on platforms that support lots and lots of hardware threads. So if you're looking at sort of like between 50, 60 hardware threads, that's a lot of space that you've got to provide. So on the Ice Lake system, we will support a terabyte of memory. I was reading through the thread in the program, the chat thread, and someone was asking, is it really true? Yes, it is true. You can support up to a terabyte of protected memory. Now, the way we do this is to not support just one physical range register of protected memory, but in fact actually to support up to 8 range registers. Now the reason for this is that server memory is extremely complex in terms of the configurations it allows. And just to get a little geeky for a second, right, you have one memory controller has multiple channels, typically up to 3 channels of memory, and you may have multiple memory controllers on a single socket. And the way memory is allowed to be organized at the physical level is that you can interleave not only between the memory in a memory controller across the different channels in order to give you throughput, but you can interleave, you know, across memory controllers. You can interleave across sockets, across memory controllers, across channels. And so the reason for that memory complexity is really to improve, provide performance improvements, to give an even response if you so chose. And so the reason for having up to 8 PMRRs is there are on a 2-socket system there are 8 memory controllers that will allow you to configure 1 PMRR for each memory controller, and therefore there is a restriction or a capability that supports a maximum of, let me get this right, a maximum of 512 gigabytes per socket, and so on a 2-socket system that gives you a full terabyte. The other thing I wanted to talk about in this generation is what ISA it's going to support. So one of the things that we've been working on is you know, extending the instruction set. Ice Lake server will support the what was published as the SGX 2.0 ISA set. So that's what we refer to colloquially as EDMM, enclave dynamic memory management. That's a feature that has long been asked for, and that will be available in Ice Lake server, as well as the regular instructions that everyone is used to, that we've supported so far. It will support what we refer to as flexible launch control, which means there is the enablement basically doesn't require a certificate from Intel. That was a feature that we enabled on our previous generation Xeon-Es. That's certainly going to be part of that architecture. So that's the ISA, and we've been working for quite some time now on you know, the basic enabling for that. Those of you are sort of like avid fans of the Linux kernel library, the Linux kernel mailing list, you will notice that SGX, the base driver, was recently included as part of the 5.11 kernel. So that's very good news indeed. We get ourselves out of we have a, you know, the upstreaming of the basic driver versus the out of tree driver that a lot of enabling has been using. We can now use the 5.11. I believe the SDK that we provide sits on top of that happily. On top of that, there's also a couple of test patches out, which I'd highly encourage people to go and look at and play with. One is for those of you that are looking to wring out as much performance of the system as possible. I was referring to that complex memory architecture earlier on. There's a patch that supports NUMA memory. So NUMA stands for non-uniform memory architecture. That allows applications to say, okay, I'm running on this processor over here on this socket. I want memory that's locally. I want secure memory that's attached to my local socket, and that gives performance improvements because you haven't got to travel across the memory coherency bus to get access to that memory, which, by the way, is also encrypted. We've added that as a feature as part of Ice Lake Server 2. So there is a memory coherency bus. I believe it's called UltraPath Interconnect. This is basically a bus that connects the two sockets and allows memory to be shared coherently from one socket to another. That's a user accessible bus, and so we provide encryption across that as well for SGX traffic. Now, I was hoping that I would have a white paper, ready, and I could point to for this conference. Unfortunately, the internal systems at Intel didn't quite get me there on time, but I promised to share with Edgeless and the OC3 community as soon as that white paper is up on intel.com. This will give more details about how we, designed and built Ice Lake Server, the problems and the challenges that we overcame in delivering that. One big thing is that yes, there are multiple sockets, but the same attestation architecture that people have come used to, the data center attestation primitives, DCAP, will remain the same. So at the top level, you'll still have a single key for the platform, and there's a big challenge in making that all happen. And so we put those details in a white paper along with some of the other bits and pieces about how we're encrypting memory across the coherency bus, and how you use these PMRRs. So that will come in a white paper, hopefully very, very soon, and we will share that as soon as we can. So that's Ice Lake Server. I'm sure there will be questions at the end about this, which is why I spent a fair bit of time on that. Oh, I'm just looking at my notes here. Did I mention KVM? I don't think I did. So the other patch I should have referred to. So we had the NUMA patches for memory performance. There's also patches to KVM for supporting SGX in guests that are being hypervised by KVM. So those patches are also out, and hopefully will get upstream very, very soon. Please go test them out. The ecosystem, the way it tends to work with the kernel community best is to really show that it's wanted and is being used through the tested tag. Ultimately, the NUMA ones might be a little more difficult, as no one has the hardware to support the NUMA pieces just yet. But the KVM piece, I think, is especially important and especially valuable. And so take a look if you can run and test. I would highly encourage folks to do so. So that's the hardware side of things. I think I wanted to spend a little time about talking about the software ecosystem and where we're going to head. And so the first thing I wanted to talk about was this paradigm statement I made earlier on. And so if you look at how we started with SGX and how ecosystems build out, graphics and machine learning is a very, very good example here, right? So if you look at how the machine learning world is built out over like a 10-15 year period, right? First of all, you have basic graphics, low level ISA support. They build out sort of like shaders and kernels, maybe some assembly. Then you get another layer of abstraction, another layer of abstraction, to the point where you've effectively invented a new paradigm building on top of an existing hardware layer. And I certainly view confidential compute as having, excuse me, as having the potential really to behave in a very, very similar way, to the point where, and you'll see as I go on, that I think the future is really in how we get above and beyond just talking about, okay, what TE am I using and what enables me to talk about that TE, right? So we spent a lot of time in the recent past working on providing SDKs, whether that be the SGX SDK, the Open Enclave SDK, Fortanix has an SDK. There's lots of SDKs appearing, and that's still you have to be pretty much an expert, which causes another problem, which I'll talk about in a second. And so we need to find ways to rapidly move up this stack in order to fully embrace and deliver value to a wider reach. So as we increase abstraction, our ability to reach a different level of programmer, and therefore more use for confidential computing will increase. And so you can see this with AI, right? You have data scientists now being programmers through OpenVINO, TensorFlow, PyTorch type of mechanisms, whereas if you gave them, the graphics hardware definition and told them to go program that, they go, I wouldn't know what to do with that. And I would posit that TEEs and the use of TEEs and ancillary technologies, whether that be homomorphic encryption or MPC, has to rise to that level where the people that are using it don't necessarily fully understand everything that goes on below them, and that our job in this community is really to find a way to that point. And so you can see some of this starting to occur, right? Certainly with our own SGX partner ecosystem, we started with this ability for people that really want to and have, lots of understanding about all the security issues that go along with this. We're providing, there's lots of tools in this space, right? I've mentioned the Open Enclave SDK that we are contributors to. We also have our own SGX SDK, which is a less open but is publicly inspectable SDK. The good folks at Red Hat are building out their infrastructure. It's more of a deployment mechanism, but effectively it's a mechanism for getting software out there. And then people may be unfamiliar, but we spent a lot of time in the blockchain space. There's a company called R3 that have their own conclave capability that they've recently announced. And there are a few others that are that are in this. There are others that are in this sort of like space also. But what we're also seeing is that using those requires a great deal of expertise, and there's a lot of value in moving us towards can I get some protection quicker? And this is where a number of companies, and Juno Fontanic, Scone, Ant Financial with Oculum, Microsoft, I think recently with Mystikos, I think it's called. See if I can recall any others. The Linux kernel library, SGX LKL from Imperial, and then Graphene as well. Mona Vij, I believe, is giving a talk on her work in this, and Intel is working hard. And these are really about taking existing applications and packaging them to work inside a container. Now, you don't get all the security guarantees, or what I should say is, you don't get the tightness of the security boundary that writing your own code allows you to do, but it does give you a capability to say, hey, I've protected a certain amount of my code. I can get that value quicker, and deployment is faster. And I think that's going to be a valuable tool again in helping us reach a broader set of community. Intel doesn't take a purist view on this, right? It's these are both legitimate strategies that you may want to deploy for your technologies. And our job is to, continue to make the use of these types of capabilities easier and easier and easier. So this is where the Confidential Computing Consortium comes in. And so I'm trying to think now, back in not last year, the year before, so that would be 2019, early 19, we sat down with a number of our the big players in the ecosystem and said, hey, we understand that just Intel writing an SDK is not enough. We need to provide a forum where folks can coalesce around this mission of providing security data whilst it's in execution. And so we formed with a number of companies the Confidential Compute Consortia. That's growing and growing. I believe Dave Thaler will give a talk later on today. Stephen Wally has been on before. I believe we have a booth here, and so I would encourage you, if you're not a member and you're interested in becoming a member, please go and talk to the folks in the booth. They will happily tell you about that. And I don't want to steal any of Dave's thunder. I think he's going to talk about the projects that are in there, and all projects are welcome. And we want to see this whole segment grow, because I think there's a long way to go in terms of what it can actually achieve beyond what we've got in the space. And so what I wanted to talk a little bit about before the end here is part of my role now is to really poke at what the future is going to look like. And so if I imagine that the existence of TEEs are just prevalent, what sort of things am I going to be interested and worried about, and what I think are your future challenges, right? Obviously, Intel will, try to figure out in this space, but I think this is what raising the paradigm means. How do we use these types of capabilities without really worrying the coder too much about how it all happens underneath? And so automation, I think, will be the ultimate scaler. And how is that going to occur? Now, remember, the premise for all this was we're providing you with protection from as the platform is being software is being executed and code is being processed on platforms that may be owned by someone else. And if someone that someone is then providing you with capabilities that say, you just write your business code and I will take care of how that gets, compiled, executed, scaled, right? What does that mean for confidential compute? And I think that's something that we have to spend more time thinking about as a community, looking for novel uses of the TEEs and how we provide abstraction of the use of the TEE to the guy that's just writing business code. But we're not just talking about, a single application. Many of the ways that the data is being processed is firing off. If you look at microservices or pods of containers, right? You're going to have many TEEs running, and so compositional trust and the testability of all those sorts of environments is going to become key. And I think we have only really started going down the road of what all this means, and I think there's still a lot of work to be done in that space. And then having lived through Spectre Meltdown, Foreshadow, and others, it's clear that the environment is going to be heterogeneous, both from a TCB perspective over the long time, right? That we will add features. Some attacks will get mitigated through different ways, and if we're concerned about these sorts of things, we're going to have to deal with heterogeneous TCB environments as trust compute based, as well as as we develop different TEs for applying to different scale, right? We're going to have heterogeneous TE environments. Certainly, as we scale from cloud to edge, right? How are we dealing with that? One of the things that the CCC has been doing in this space, right, has been looking at how we, as a community, talk about attestation. Certainly, they have a proposal, and hopefully Dave will talk more about the SIG that we're hoping to form in this space. So that's my call to action: is lift your head above. It's just a TEE to think about. Okay, what will this mean for the future, and how will we address these scaling issues? Because I think they're going to be very, very important for getting us beyond where we are today. So wrapping up, I think we have a whole bunch of opportunities available to us. Confidential compute is as a paradigm is creating those. We need a vibrant ecosystem to power it and to get to scale. That's completely obvious to me. We have hardware coming to power that, both at the data center and the edge at scale. So we need to combine those two, bring them together, and then finally think about how we go beyond what we've got today in terms of where will this take us? How do we make confidential compute almost invisible to use, and how do we deal with the challenges that the dynamics of how code is going to get written in the future, and how we combine the promise of confidential compute into those sorts of systems, I think is the future challenge that we need to rise to. And with that, I think I'm ready for questions.
Thank you. Thank you, Simon. Oh, I double hear me. Let's see. Okay, that's off now. Perfect. Thank you so much.
You're welcome.
Saw that we have a lot of questions in the chat, and I think we have time for 2 or 3 of them. Felix.
Yeah, I collected a few of them. Yeah, thank you, Simon. Great presentation. Awesome stuff. I particularly like the AI or computer vision analogy with CC. That was quite insightful. So there's a question from Sebastian Eckert. Simon, can you also comment on the recent announcement on FHE and Intel's newer ideas there?
So I don't deal a lot with the FHE side. I would say this, right, is that there's still a lot of work to be done in the FHE space. And to sort of like bring the CCC in here for a second, right? CCC did discuss whether the scope of the community should include FHE. We decided that when CCC talks about it, it says yes, it's in the space, but at the moment that's not it's not mature enough that we want to move forward with that. I think there's still a lot of work to be done there. That particular reference was to a piece of work that I think that we've signed up with Microsoft for a DARPA program, and so I'll leave it to the. I don't have any additional details to add beyond the press statement, but I'm sure as the DARPA program rolls on, they'll release more stuff.
Yeah, makes sense. Next question, very specific question. Will there be AVX 512 of the new ice lakes inside SGX enclaves? That sounds like a great feature to have.
I believe the answer to that is yes. I will double check, but there's AVX 512 on Ice Lake. I'm pretty sure. Ice Lake has been in development for quite some time, so I will take that one and get back to the individual if you folks can provide me with an email address, and we'll just get confirmation on that. But I'm pretty sure the answer to that one is yes.
Okay, great. Then I think we ready for the next talk, right, Anna?
Yeah, I think we are. Thank you, Simon. Thank you so much.
Welcome.
Maybe you're here for a while and people can contact you via the chat.
I'm going to hang around as much as I can. There's lots to do today, but I will stay around and folks can ping me. Yes.
Perfect. So you can just try to get a little talk via chat with you. Thanks so much.
You're welcome.